Okay, now we're going to use the identities and see some newer problems here. I'll do a quick review. Let's see for this first part. Let's review something that's very, very similar, exactly what you're going to be doing, but with identities. This is the way you've seen it before in the past. Okay, so if you're multiplying this, right, you're asking something like this, you're multiplying two polynomials, you would do what, right? You would do the FOIL method, right? So you do this one times each of these, so that'll be x times x, x squared, x times negative 5, negative 5x. And then this one times these two, so that would be plus 2x minus 10, right? And then you combine the like terms, and your final answer would be, right, combine like terms here, so that answer would be x squared minus 3x minus 10. So this is review, right? You remember that. Now look at how you're going to see this, but with identities. Now, with identities, it's going to look like this. Number one, you'll see something that looks exactly like it. Sine plus 2 and sine minus 5. Right here I had x plus 2, x minus 5. But now you're going to see, obviously, with with these trig functions, so sine plus 2, sine minus 5, it's gonna pretty much work out the same, right? How would you multiply this? Well, the same thing, you distribute. This one times these two, that would be sine squared minus 5 sine, and then this one times these two, right? Plus 2 sine minus 10. Exactly how we did this over here. And then these middle terms or like terms, we can add them. So final answer would be what? Sine squared minus 3 sine, right? Negative 5 plus 2, negative 3 sine theta minus 10. Okay, well, there's going to be more to it. Let's do another one similar to this, where you're multiplying two binomials. Here's number 2. Number 2, what if you have something like this? Sine theta plus cosine theta quantity squared. That would be, does that mean just to square this and to just square this? No. You know that this means that there's two of these being multiplied. Sine theta plus cosine theta, and then another one, sine theta plus cosine theta. You better not just square this and this. That's not right. And then we FOIL this out. We distribute this one times these two. This one times these two. Let's do the first one here. Sine times sine. Sine squared. Sine times cosine, you can't multiply it, so you just write sine cosine. You just write them together like that. And then sine times cosine, or cosine times sine, is the same thing, but let's just write it in the same order. Sine times cosine. And then this one that you're doing, cosine times sine, or let's just write it sine cosine, right? Keep it in the same order so that we know that these are going to combine, right, with the same thing. And then cosine times cosine is, all right. So it's like if you had x times y and then y times x, it'd still be xy and then plus, and then just write xy like that. You don't want to write yx and then you think it's two different things. Same thing here. Sine times cosine is sine cosine, and then cosine times sine, or sine times cosine, is another one. So these combine like terms. What would a 1xy plus 1xy be? That would be 2xy, right? So the same thing here. These combine. So you're left with sine squared plus 2 sine cosine, and then plus the cosine squared, right? And some of you may think that that's it, that you're done, and this is the final answer. But it's not. Look again. Okay, anybody notice anything? Well, here it is. Remember we talked about this really famous one right here, sine squared plus cosine squared. Anytime I see a sine squared added with a cosine squared, what's the answer? 1. So the only thing is here they wrote them separate. I can move this over here, right? Because all these are 3 pieces being added. But I can move the sine squared and combine it with the cosine squared. And then this, I mean, you can move it, you can move them there, you can move it in front, but, and then followed by this part, right? And we know that what? Sine squared plus cosine squared is 1. So the answer is 1 plus what? 2 sine cosine. Right, these two make a 1. Sine squared plus cosine squared equals 1. Remember, we got to remember we're using these new Pythagorean identities. Okay, so every time you see something with sine squared or cosine squared, or also be on the lookout with tangent squared, secant squares, and there's, yeah. Okay, so that's number 2. All right, so you'll have some like that where you're multiplying two binomials. Here's the next part. This one's actually a little bit easier. The next part looks like this. Let's do again something review, something that you've done in the past. I mean, this one, like I said, it's even easier. What if you have this? 5 times, or parentheses, 3x minus 4.
Oh my God.
Wow, this is simply what? Distributive property, right? Distributive property. So that would be what? Well, I know some of you can like just see it and know the answer, but I need you to actually slow it down and do the steps, because here it's numbers, but when you see it with identities, you're not going to be able to jump and do it as easily. So again, you understand that this, whatever's out here, has to be multiplied to what? And distributed. That's why it's called the distributive property. It has to be 5. This outside 5 has to multiply first to this one, and then minus, and then that 5 also multiplies to the next one, right? So this is a step you can't skip. I mean, with numbers you can get away with it, but when you see identities here, you're gonna have to do a step at a time. All right, and then while You already know for numbers we just multiply 15x minus 20. All right, let's do now one like this, but what you're going to see with identities. And it's going to look very intimidating, but it's not. All right, here it goes. 1. What if I put sine of x parentheses secant of x plus cotangent of x close parentheses equals tangent of x Here's the problem. Here's a math problem and there's no numbers. Interesting, huh? All right. What's the good thing about this one? This is one of those problems where, remember when you have the equal sign, what this means? This means we kind of already know we're going to start with this side. We're going to start with the left-hand side. Sometimes there are problems where you start with the right and you make them equal the left, but here I'm setting it up where we're starting with the left-hand side, with the left side over here, and we're going to eventually make it get us to this answer. Like it's like giving us the answer, what it's supposed to equal to already. So really we're only going to work with this part, and this is the part where you see that it's distributive property. So let me copy it again. Sine of x secant of x plus cotangent of x. Okay, so if I distribute here, right? This is the one where I told you, well, you can't skip the steps. What does it mean? Well, this means that you're going to multiply this sine of x to what? The first one. Plus this sine of x to what? The second one. And if there was more terms in here, well, you'd continue the pattern here, right? Okay, now what? Right, so we distribute. Now we do what? Well, signs are fine, but remember we want to change what? We've done this before. When we do any of these simplifying or multiplying, we want to have only sines and cosines. So change to what? Sine or cosine. Right? So I got sine of x, which is sine over 1, times secant. Secant is what? 1 over cosine. Right? Plus sine of x is okay. Sine of x is sine of x over 1. Remember when we're multiplying, we want to see fractions. I want to see a numerator and a denominator. Sine of x is sine of x over 1 times, and what's cotangent? Cotangent is cosine over what? Sine. Okay, so I could see over here with these cancel here, sine and cosine. I'm sorry, sine cancels with sine, so you're going to get plus what? Cosine x over 1 is just cosine of x. And if we look over here, that's what we want to get, plus cosine x. So I got this second part over here. And what happens here? Nothing cancels. So you're left with sine of x over cosine of x. But this says that it has to equal to what? Tangent of x plus cosine of x. Oh yeah, but what is sine over cosine? Sine over cosine is what? All right, there's that one. One more. Okay, here's the last one. got cosecant theta times tangent theta minus sine theta, and another one of these equal ones. So that's good, right? Because it's like we're getting the answer here. We know what it has to eventually simplify down to. Is equal to what? Secant theta minus 1. All right, so we start here with this. We start with this, and we're going to make sure that we get this answer when we're done. All right. So what do we do first? Cosecant theta, tangent theta minus sine theta. Distribute. Right? This is just distributive property, so that's cosecant tangent minus cosecant sine. Right? These are multiply. Cosecant times tangent, cosecant times sine, right? Distribute. With the minus in the middle. Then what? Change everything to sine and cosine. I don't want to see cosecants. I don't want to see tangents. And sine is okay right there. But what is cosecant? Cosecant is 1 over sine. Times, what is tangent? Sine over cosine. Well, I can already see what happens here. These are going to cancel. But let's not get out of step here. Let's continue here. And then what's this? Cosecant is 1 over sine times sine is what? Sine over 1. And then I could also see that what? These will cancel out. If these cancel out, I'll get minus what? 1 over 1? That's going to be minus 1. Is that what it says we're supposed to get right here? Yes, I got this part. And what's going to happen here? You're going to be left with what? 1 over cosine. But we know that 1 over cosine is equal to what? 1 over cosine is equal to secant theta. So there it is. You've proved it. You proved it that yes, this, when you distribute and you simplify it down, does give you what? Secant theta minus 1. All right, there you go.